The purpose of this note is obviously to be able to draw motion diagrams, or in other words, to draw diagrams of an object that's in motion. But you'll see for the first half of your page or so, it actually starts with a lot of important definitions. Some things that we've already seen and talked a little bit about, especially displacement and velocity, but also acceleration, which I'm sure you've heard of before, and we'll come up with more of a mathematical definition for. And before we even get into any of that, we actually need to step back a little bit and also talk about this concept of position and exactly how that's different from displacement that we've already talked about. But because these definitions are so important and can get a little bit tricky to understand, I'm going to save that to actually talk about in class so that I can give you a chance to really ask questions and respond in real time. What I'm going to focus on in this video then is the bottom section, because before we really get into calculations, we can still draw motion diagrams. So we're going to try and draw diagrams that describe an object's motion. And what we're really doing then is drawing frames of how an object is moving over time. In other words, we're representing a certain object at different either seconds in time, or maybe tenths of a second in time, or maybe hundredths of a second in time. But each frame that we draw represents an equal amount of time going by. And then we draw the object as showing what its displacement is doing, essentially how far it's moving over that time. But of course, we don't actually have to draw the objects themselves. In physics, we try and make things as simple as possible when we're doing these diagrams. And so our objects that we draw, regardless of what the object is, will just be represented as something very simple, like a dot, or in my case, I'm going to draw them as just small circles so that they're a little bit easier to see than a dot. But on your page, you can just do them as dots. You'll see in our example at the bottom, you could use plus signs or X's or stars, just some simple shape that you can easily use to represent that object in motion. So the very first one is just a car moving at constant velocity on Highway 401. So again, these different frames that we draw, or in other words, these different dots or circles that we draw, are going to all be occurring at equal amounts of time. And so if you're going at a constant velocity, it means that you are changing your displacement or changing how much ground you're covering the exact same amount each second that goes by. And so if I draw one small circle to represent where the object might start, 1 second later, or maybe a tenth of a second later, if the object is, let's say, here, that space between those two should be the same space that's created between the second dot and the third one, and the fourth one, and the fifth one, and so on. And so mine is not perfect, and yours does not have to be perfectly to scale. But what you're doing there when you put yours down onto your page is try and make them as evenly spaced as possible. And so when we see a group of circles or dots or plus signs, whatever they are, being evenly spaced, it represents a specific kind of motion diagram. In this case, what this overall pattern is showing us is exactly what the question has laid out: constant velocity, equal spacing as equal amounts of time go by. That's what's true and characteristic of constant velocity. That situation is going to change a bit as we have a car that rolls down a hill when its parking brake fails. And again, we don't have to draw a car, we'll just use circles, or we could use dots even. But just to kind of give us a reference point, that is going to be the hill that the car is going to roll down, and I've given some room at the bottom for it to continue rolling after it gets to the bottom. And so the car might be here at the very top, at the very beginning, and just as it starts to roll, in that first split second as it's just starting to roll, it's not going to move very far away. So the next dot is going to be very close, maybe pressed almost right up against it. But then it'll start to roll and get a little bit faster as it goes, and that'll allow it to cover a little bit more ground in between the next second that goes by. So it's a little bit farther away. After another second goes by, now it's gained even more ground and it's spaced out even further. And by the time it's near the bottom, it's spaced out quite a bit. And so you can see with those first 5 circles that I've drawn, the first 2 are very close, and then they get farther and farther apart as we get to the bottom. But by the time we get to the bottom, that spacing that we have should stay about the same. So you notice the last 4 dots that I drew, I did my best to keep them about the same spacing. Because right here, we're actually showing a combination of 2 kinds of motion. In the first section, which is essentially the first 5 dots or so that I drew, that's where we've got an acceleration happening. That car is accelerating as it rolls down the hill, specifically caused by gravity, which is a factor that we'll see a lot come up in this course. By the time it actually gets to the bottom, though, it's now rolling on level, flat ground. And eventually, if I let this go for long enough, it would start to slow down again. But for now, I'm just showing what it would do in the first few seconds after it reaches the bottom. And in those first few seconds, it would essentially continue to roll along at the pattern that we've already seen, which is even spacing, meaning constant velocity. The bottom example now is really just asking you to take a look at the plus signs that are there. The plus signs are just representing the same thing that my circles were before. It's representing some object, and the question is, can we tell from that diagram there, is it speeding up or slowing down? And do we know, is it moving to the left or the right? And is there even enough information to tell? Those are all the questions I want you to think a little bit about, and we'll of course take that up in class and talk in more detail about the descriptions and the definitions at the top of the page.